Okay, so, whoops, back where I left off. We were finding numbers that factored to give me 35. And if they factored to give me 35, then they also need to combine together to give me 12. So 35. 1 times 35, 5 times 7. I can stop because these two combine together to give me 12, which is what I want. 3 is the GCF. X goes in 1, a positive 5 goes in 1, and a positive 7 goes in the other. If you were to multiply these two binomials out and then distribute the 3 to the answer, you would end up with this trinomial. Okay, so what's next? Factor completely. Okay, looks like A, the leading coefficient, does not equal 1. So step number 1 is to check for a GCF. Always check for a GCF. 5 is a prime number. That's just 5 times 1. 16 is 2 times 2 times 2 times 2. Doesn't have a 5 in it, so it doesn't matter if this one does over here or not. That's 2 times 2 times 3. So there's no GCF. So that means we're going to have to do what we call the AC method. Okay, and the AC method means that we're going to temporarily change this binomial that does have a leading coefficient into one that doesn't have a leading coefficient. And we call this the AC method because we're going to multiply A times C. So we're going to multiply 5 times 12. And when we rewrite this trinomial, we leave the 5 off. We copy down the middle term exactly. And now we're going to, down here, we're going to write whatever the product of 5 times 12 is. If I'm right, 5 times 12 is 60. I'm checking my calculator because sometimes my multiplication skills are not what they used to be. So now I have a temporary problem that I'm going to work with. This makes it super easy because I can work this one the same way that I did all the other ones. I've got to do the factors of 60. Okay, and it's a positive 60, so I'm okay there. And this one's a positive, so that means I don't need to worry about any negatives. So 60, 1 times 60, 2 times 30. And I'm looking for 16. 3 times 20. 60. 4. What is that one? 60 divided by 4. That's 4 times 15. And then 5. We know 5 times 12. That gave me 19. That gives me 17. I'm getting closer to 60. So what about 6 times 10? 6 times 10 multiplies to give me 60. 6 plus 10 gives me 16. Now, obviously, you don't have to go through all of these if you can kind of look at this and get an idea of what it is. But this will always get you going. Just start dividing by, and you only want to do numbers that will go into it evenly. So we found our correct pair. So we're going to write B plus 6, and B's and 6's, I have to be very careful, and B plus 10. Okay, now this is not the answer, so be very careful. What happens is you guys only hear half of what I'm doing. You do this part just fine, you do this part just fine, and you think, oh, I'm done. You are not done, because this trinomial is not equal to this one. This just got us going. But because we created this 60 by multiplying by 5, we have to undo that multiplying by 5 by dividing by 5. And we're just going to divide those two numbers right there by 5. Now that we've divided by 5, if it will divide. 10 divided by 5 becomes B plus 2. That's great. So that binomial is now b plus 2. This one's not going to divide. We do not change it to a fraction, to a decimal. We do not leave it as a fraction. What we do is we take this divisor, which will not go into 6 evenly, and we just swing it up in front. So this becomes 5b plus 6. Now, if you were to multiply these two trinomials together, you would get this. If you multiplied what we just had to begin with, b plus 6 times b plus 10, we would not get this. We would get this one, and this is what we were trying to get. Multiply 5b plus 6 times b plus 2, and you will get 5b squared plus 16b plus 12. Okay, let's try it again. Remember, this is number 17 and number 18 on that worksheet that you will need to do some problems from. So 10 is 2 times 5. We're checking for a GCF. 17 is a prime number. That's just 17 times 1. And 20 is 2 times 2 times 5. So no GCF. This one, it's 17 times 1, by the way. There's no GCF. We have a common factor in these two of a 2, but this one doesn't have a 2 in it. So, AC method. We do the AC, we call it the AC method because we're going to multiply the A times the C to pretend for just a minute that this is, So, positive 10 times negative 20 is a negative 200. Okay, so I'm going to do it over here. So factors of negative 200. Now they need to combine together to give me a negative 17. So I know it's not 1 and 200. I know it's not 2 times 100. I'm going to jump in and try to get numbers that are a little bit closer together. So let's start with 10 times 20 because we know that multiplies together give you 200. So if one of them has to be negative, so we know 10 times 20 gives us 200, but we need a negative 200 and we need it to combine together to give me a negative. So that means the bigger number needs to be negative, this one. So that combines together to give me a negative 10. So I'm not too far away from 17. So what about, let's see, can I do 200 divided by 12? Nope. 200 divided by 9? Nope. 200 divided by 14? Nope. 200 divided by 15? Nope. 200 divided by 16? Nope. 200 divided by 18? Nope. 200 divided by, I'm going to go back the other way. I said, let's do 8. Yeah, 200 divided by 8. So that means 8 times 25. 8 times 25 will give me 200. I need this one to be negative. So what happens if I combine together a positive 8 and a negative 25? That means I get exactly what I need, a negative 17. So did you see how it was just trial and error? I tried a whole bunch of numbers. I started at 10 because I had those two, and then I knew that it needed to be kind of close because 17 is not very far away from 10. So I tried to go up. I tried 11, I tried 12, I tried 13, I tried 14, I tried 15. And then I said, well, if I won't go up that way, let's go back the other way. I tried 9, it didn't work. I tried 8, and it worked, and that was the one that I needed. So remember, I'm going to do m plus 8, and I'm going to do m minus 25. That's not my answer. I got that by dividing by 10. By multiplying by 10. So now I've got to divide by 10. None of those will divide evenly, but before we swing this out in front, we do need to reduce it. I'm going to go ahead and stop it right here, and I will pick up on the next video.